Let's say that you're now having trouble with something in which you want to write the formula. In order to write this formula, the first thing that you should look at is what is occurring with the name. When you're looking at the name, you again want to be focusing on what the first element is. If the first element happens to be a metal, then you know you are working with something that is ionic. Because you are working with something that is ionic, you want to identify the charge of that metal. If the metal happens to have a Roman numeral, then you've already figured out what the charge of the metal is. It has to match the charge that the Roman numeral states. On the other hand, if the metal does not have a Roman numeral, then you need to look on the periodic table. From the periodic table, you'll be able to see the oxidation numbers above the symbol of each of those metallic ions. That means that there is only one option for the oxidation number. Now that you have the charge, you then want to decipher what is occurring with the anion. In general, many of your anions can be found on the yellow sheet. Those happen to be polyatomic. If your polyatomic anion is on the yellow sheet, then you can just notice the charge, and with that charge, you can join the two ions together. You can join those by, again, looking for the least common multiple. So if you have something, for instance, where the oxidation number is +2 for the metal, but the oxidation charge on the polyatomic ion is -3, then your least common multiple would be something like a 6, which would mean you would need 3 metals and 2 polyatomic ions. On the other hand, your anion might be a monatomic ion. You'll know if it's monoatomic by the fact that there is only one type of nonmetal. Because only one nonmetal is present, you want to go ahead and find it on the periodic table. Again, nonmetals come in 4 families. Those that happen to be in the carbon family are -4. If they're in the nitrogen family, they'll be -3. The oxygen family, -2. Or the halogens, -1. These ones will also have ended with IDE. Remember that some polyatomic ions also end in IDE, so not all of these are going to be monatomic. If, on the other hand, your first element has not been a metal, then you know you're actually working with something that is covalently bonded. The first thing to notice when you're writing the formula is whether or not this compound happens to have the word acid in it. If it does, that does in fact mean that you have an acid, and all acids start with H+ ions. The next thing to notice is how the acid has been designed. If the name happens to have hydro as an initial piece to the acid, then you know your acid is binary. Figure out what the element is that is the nonmetal. Identify its charge, just like you might if you were working with something that was ionic, and then join it with your hydrogen ion. You're going to need multiple hydrogen ions if your charge is greater than -1. So something with -2, you'll need more than one hydrogen. On the other hand, your acid might not have a hydro. And again, most acids do not have hydro in their name. That therefore means that your acid might end in -ic, or your acid ends in -us. These mean that you're going to go straight to your yellow sheet. Replace the ick with an 8 and find that polyatomic ion on your yellow sheet. Replace us with an ite and find that polyatomic ion on your yellow sheet. Once you have those ions, you'll again take the ion, whatever it might be, and join it with hydrogen. The final one is if instead all of the elements listed in the formula happen to be nonmetals, and you are a binary compound that you're looking at. If it is binary, then that means you're simply going to follow whatever the prefixes say. Remember that each prefix has to match the element it is on. So if it says that you are looking at dinitrogen, that means that there are 2 nitrogen atoms. And then you'll just write the formula from there. All right, let's do some examples. So let's say first that you are looking at a name that says barium hydroxide. Again, the first thing that you should notice is what is true about the first element. In this case, barium. Barium is on the left side of the periodic table, which means that it is in fact a metal, so you have an ionic compound. Since there is no Roman numeral in the formula, you need to look at the periodic table. Find the element barium, notice that it is in the second group, and therefore is positive 2. You're now going to look at the second name, and that second name is the anion. Since our anion happens to be hydroxide, we want to look first at the yellow sheet to see whether or not it's a polyatomic ion. If we cannot find it, then the IDE ending means that it's probably a monatomic ion. Yep, if you found it, it's OH with a -1 charge. If we look at our positive 2 and our -1, we just need a common multiple, and in this case that multiple is going to be 2, which means we just need 1 barium and 2 hydroxides. Alright, for our next example, let's say that you are looking at hydrochloric acid. Again, the first name is not representing a metal. Hydrochloric is not a metal. Therefore, we know it's covalent. We can also see that it's an acid since it says acid as the second name for the compound. We now look to see whether it starts with hydro, and in this case it does. That means that you're going to be joining an H+ ion to some sort of nonmetal, and in this case that nonmetal would be chlorine. Find that nonmetal on your periodic table. It's part of the halogens, so it's got a -1 charge. Using your common multiple, we only need 1 hydrogen and 1 chlorine. This is going to now be hydrochloric acid, HCl. If instead your acid said something like sulfurous acid, you again know that you are working with a covalent molecule, which is in fact an acid. In this case, your acid does not have hydro in the beginning, and again, most of them do not. You're now going to look for your H+ ion to be joined with something that has sulfurite. No, that's not quite right. Sulfite would now be the ion. Use your yellow sheet to find the sulfite ion. So we're replacing the OUS ending with an ITE. From your yellow sheet, you see that it's SO3 with a -2 charge. The common multiple here would be a 2, so we'll have 2 hydrogens with 1 SO3 ion. Let's say instead that you are told that you have dichlorine monoxide. Again, we see that we do not have a metal to start, since chlorine is on the right-hand side of the periodic table. We do, however, have a binary compound, as we have chlorines and oxygens. The prefix di goes with the chlorine, so Cl2, and the prefix mono goes with the oxygen, so O with just one for the subscript, which you don't have to write in. Let's try one more and say that it is in fact iron 3 phosphate. In this case, iron is metallic, so we know we're working with an ionic compound. We also see that our metal, iron, happens to have a Roman numeral. Since it's a Roman numeral of 3, it's positive 3. We also have phosphate. That happens to be our anion, and finding it on the yellow sheet, it is PO4 minus 3. The common multiple between 3 and 3 is 3. So we just need one iron and one phosphate ion.